This is what we looked like in the 30s and 40s. I was 17 when Woodstock happened in 1969, and I remember what we looked like then. One of the fiercest debates in all of nutrition is what happened after that to cause us to gain so much weight, especially in America. Some say it was the rise of refined oils. Some say it was the food pyramid, or fast food, or the multi-billion-dollar chemical flavoring business that made it impossible to stop eating Doritos. Or was it food engineering that combined sugar, fat, and salt to hit a bliss point? Or carbs, fat, sitting on our tushes? But what if there was an amazing study starting in the late 1940s that tracked 15,000 Americans, including their children and grandchildren, and measured everything that could be measured up to the current day? I'm talking about bone density, brain scans, sequencing their DNA, a brain donation program after their deaths, and tracking details of diet and exercise. There is no other study like this, not even close, and that's why it's thought of as one of the greatest advances in medicine of the 20th century, up there with antibiotics. Everyone has heard of the Framingham Study, but how many people know much about it besides research scientists? I know some very popular doctors who think they do.
So another piece of fraud and misrepresentation was of the Framingham Study, which is a large 30-year study.
Dr. Chaffee is in a position of trust as a doctor, and he has 300,000 subscribers. And yet he didn't do a simple Google search to see that the study is going strong at 75 years.
The association of cholesterol and heart disease came from something called the Framingham Study, which was in Massachusetts, started in 1948, carried on for several decades, where they followed up 5,000 people.
Dr. Malhotra got 2.8 million views for that clip on the Joe Rogan show without doing a simple Google search either. But it gets much worse.
Now, what's interesting about Framingham is when you look at the associations of total cholesterol and heart disease, it was only there when your total cholesterol, the significant association, was only there if it was over 300 milligrams per deciliter. Very few people have total cholesterol that high.
The simplest Google search would turn up the Framingham Study's webpage where they score risk. A higher number is higher risk. Note that the numbers get higher for each increment of higher cholesterol, and above 200, the numbers are comparable to smoking. Note the Framingham Risk Calculator is the most widely used and respected in the world.
Another interesting caveat, most of that data on the development of heart disease was only up to people who are 50 or 60.
And that's how you can tell he's never looked at Framingham data. It's all public, and they collect and report it until the participants die, as Agnes DeCenzo just did at 105.
So the original Framingham study actually found that if you dropped your total cholesterol by 1 milligram per deciliter, you actually increase your coronary mortality and total mortality by 11%, okay? So as your cholesterol went down, your mortality rate went up, and heart disease deaths went up.
I don't know where he got that from, but it wasn't from Framingham.
But the American Heart Association 2 years later fraudulently claimed that the Framingham study found that a 1% drop in total cholesterol equated to a 2% drop in coronary heart disease risk. Okay, that's academic malpractice, all right? That's fraud.
Actually, the American Heart Association must have read the Framingham studies because they accurately reported what Framingham has published for 75 years. If there is academic malpractice here, I'm going to go with the social media influencers who didn't even do basic fact-checking. I got special permission from the NIH to tour the Framingham campus with my camera rolling and to interview the director, Daniel Levy. He has a wonderful book that has aged well, A Change of Heart. Our interview wasn't all boring science. There were episodes of high drama in the world of heart disease research. Some of you know I was asked by TEDx Boston to organize a Longevity Day October 1st with the most knowledgeable longevity researchers in the world. I was so impressed with Dr. Levy, I asked him to speak, and he accepted. The title of his talk may be Choose Your Parents Well. He has 3 generations of data, including genes, to tackle the fierce debate of genes versus lifestyle. Can you imagine the changes they've seen over 75 years? I collected memorabilia of what life was like in the late 40s and early 50s in Framingham. They had some big, elaborate restaurants pre-McDonald's where they ate socially, often with entertainment, and ate real food. But despite that and staying slender, they had very high rates of heart disease. Looking at the menu of one of their most popular restaurants in the day, it's not hard to see why with what we know now. So, Harry Truman signed the National Heart Act into law, and the Framingham Study was born. This book, what a year it was in 1949, had a page on nutrition. They encouraged Popeye to pop open cans of kale instead of spinach. They were suspicious of high meat and egg diets and encouraged a more balanced diet with vegetables, legumes, and whole grains. That's not different from what virtually all longevity scientists say today. Here was the U.S. military's advice back then.
I'm just passing on what the medical officer told me. Cut out all that junk you eat and go in for fresh vegetables and fruits. And drink lots of water.
But they didn't know what caused atherosclerosis, guessed it may be a lack of vitamin B6, and it became the mission of the Framingham Study to find out. It's great to meet you.
Nice meeting you too. I'm Christine Hess. I'm the Research Center Manager here at the Framingham Heart Study, and I'm going to give you a little tour of the Research Center. I'm going to take you down the back way. It's not very nice. It's closer.
You guys have been in this facility for...
I don't even know how long. Before me, and I've been here quite a long time.
How long is quite a long time?
16 years.
16 years, wow.
Yeah.
What brought you here?
Well, that's a funny story. My mother actually worked here for about 40 years.
40 years?
Yes. And
So,
I
what was
just
her
kind
name?
of fell into it. Her name was Marion Bellwood. She was the recruiter.
Oh, interesting.
One of the original recruiters.
Oh, fantastic.
Yeah, so I kind of fell into it after I had my kids and
Recruiter for patient volunteers?
for scheduling the patients to come in.
Yeah,
Yes. So I grew up with the Framingham Heart Study around the dinner table and
Yeah.
hearing stories about it when I was a child. And
Wow.
this is a very small area, so a lot of our rooms have dual purposes. The first stop for the participants is over here in the admitting room. So they're brought in from the lobby. They go here, they do their consenting.
How often do they do this?
Every 3 to 5 years, they come in for an exam cycle. It takes us about 2 to 3 years to get through everyone.
Yeah.
Because I think in this group that we're doing right now, we're doing the Gen 3s, we have over 3,000 people coming in. So
And how long are they here for in the building?
They're here for 5 hours.
5 hours.
Between 4 and 6 hours. The average is 5.
Who are these angels
Yeah,
that do
I
this?
know. They're wonderful. I can't say enough good things about
Do you
it.
have to poke and prod them, take blood samples?
No, they love coming in for the most part. They're not compensated in any way. They have a great sense of pride being part of the Framingham Heart Study because, you hear, oh, my dad was a part of it, my mom, my grandmother, my grandfather. So they enjoy coming here.
Wow.
And we don't have to do much arm twisting to get them in.
Wow.
So they come in.
When I was thinking poking and prodding, I was thinking blood samples.
Yes, so we take about 9 tubes of blood.
9 tubes of blood?
Yes.
Ow.
Yes, so they come in fasting.
Do you collect poop too?
Well, we do have a station where we do give them a kit to take home, mail it back to a lab. It doesn't actually come here.
Yeah.
That's where we study the microbiome. So we've had some requests from people that want to give us their sample the day they come in, and we're like, no, it doesn't even come here. It goes to MIT. It goes to the Broad.
Oh yeah.
I know this looks very innocuous, but this is like Grand Central, this area right here. These are the pathways and all of the stations that the participants get to go through. You'd have their name on a label up here, and the green pin is where they are. So that person's in lab for a blood draw. And then we have these numbered pins, and then they're going to the cardiovascular resiliency station. So that's kind of how we keep track of everybody, because these stations don't go in order. Most of them we can jump around.
What's MMC?
So Mixed Meal Challenge. So the Mixed Meal Station is one of the fasting stations that we have here, and they're given a nutrient-dense shake.
Oh.
Which actually Megan can talk to you about. It's her station.
I do the mixed meal and then the microbiome station.
Yeah.
So the mixed meal is a boost protein shake.
Oh, yeah.
They drink that, and then 2 hours later we draw their blood again, and we're comparing the 2 blood draws and seeing how the metabolites in the blood react. It's got a lot of ingredients, a lot of Yeah, like glucose syrups. And then we also add a powder to it, which just adds more macronutrients like protein and carbs.
We have a glucose monitoring station.
Yeah.
I'll bring you down the hall. You can speak with David.
What does that mean? They put a patch on their arms? Or?
Yes, so he can tell you more about it, but they do wear a patch, and there's some other components to the study as well.
Nice to meet you.
Sorry about the camera in the face, but
no
it's what I do.
So I run the glucose monitoring station. Diabetes is often considered underdiagnosed.
Yeah.
These can check your blood sugar every 5 minutes for 10 days.
Yeah.
We send them home with this. We also ask them to track things like what they're eating during those 10 days, how they're sleeping, and then we do a couple days of diet tracking. It is a little more involved, so we only ask for a couple days.
Yeah.
But it's interesting because everything has timestamps, and we're able to kind of match those things and get a peek into how, well, our daily lives affect blood sugar.
Right over here is the bone station.
Nice to meet you, Chandler. So at the bone station, we use a HRP QCT scanning machine.
Wow.
It's just a seat to the scanning machine that takes cross-sectional images. It takes 168 of them per site.
You stick arms or legs in?
Yeah, we stick a lower leg and a lower arm.
I see.
Particularly the tibia and the radius.
I see.
And we can compare them to past scans, future scans, and we can see if there's any change. And also we can look at metabolites in the blood and see if there's any correlation with that.
I see.
A couple photos here right behind you. You can see cross-sectional images on the wall. And we can see inside the particular areas, the coracle area and the trabecular area.
Oh, so that's pretty awesome.
I'm going to bring you right over here to Angela.
So this is the sensory station. We're interested here in just measuring people's nervous systems for participants, just to see why
systems.
Yeah, basically we do it through a pressure test just to see why some people going through some similar different ailments will be able to experience pain in different ways. So we do a pressure test on one of their muscles, and then we add a stimulus on the other side to see if we can kind of delay their reaction to the pain over here, just to see if there's different ways you can treat people's pains in more like natural ways. So yeah, it's pretty cool. It works a lot more than you would think too. So
I had no idea.
Yeah.
Framingham, you associate it with cholesterol tests and blood pressure and weight. And
a lot more than you think. Yeah.
Oh my gosh.
Yeah,
it's crazy.
Yeah.
They also meet with a nurse practitioner, and she will ask them about their medical history since they were last here. And she also takes blood pressures, and we use one of these wonderful, because we're research and we've been doing it this way, we use a manual.
The mercury ones.
Yes,
What's
which
the
they don't
advantage?
even make anymore. Because we're research and we've been doing it this way since 1948.
You have to stay consistent.
Yeah. So we feel like these are more accurate anyway, but we only have like 4 of them.
And then you have a method they have to relax for 5 minutes and sit with their feet
Right,
flat on the floor.
feet on the floor, no talking, rest, and they take 2 blood pressures 5 minutes apart.
Wow.
And they also review the EKG that's done here and compare it to the one that they had done the last time they were here. So,
and what does the EKG tell you?
The EKG looks at the rhythm of your heart, so it will tell you if you have any abnormalities in your heart rhythm, atrial fibrillation, things like that. People are most familiar with that one. This is our little goal chart. So these are the amount of participants that we've seen since we started the study in September of 2022.
The third generation study.
The third generation only. So our goal is to get 3,374.
And is this the staff?
That's the staff. We have a great staff.
So how many people work here?
Oh gosh, I don't know off the top of my head. Over 100.
This is Mimi, our lab manager.
Hi, Mimi.
Hi, how are you doing?
Good.
We have like 22 freezers inside the Framingham.
22 freezers.
Inside the Framingham Heart Study, and they're all monitored by backups, security and stuff like that. This is one of the ones that we have, it's, online and stuff like that.
Minus 20 degrees.
Yeah, that is exactly. The minus 80s are all around.
There's minus 80s too?
Yeah, let's go see the minus 80s. These are fun.
Oh my gosh.
So we have 2 dedicated freezer rooms that have their own dedicated AC units. We have backup AC units for when, for AC units go down.
Minus 80 is for blood?
Yeah.
Because it preserves the longest at minus 80 or something?
Yeah.
Wow.
So blood, urine, some DNA.
I'm going to show my extreme knowledge. Is this a centrifuge?
It is. So we have serums and we have plasma, and the plasma will do the DNA, extraction. At least the buffy coats come out for there.
This is Chris from Plant
Hi,
Chompers.
Hey.
glad to meet you. Sorry about rolling the camera. It's just what I do. Having a camera in your face.
We'll have fun.
Yeah,
I'm looking forward to it.
Yeah, me too.
Dr. Levy is one of the most solid scientists I've ever had the honor of interviewing. But when I edited this episode, it was 90 minutes, with 60 minutes being taken up by Dr. Levy's interview in the center. And I imagined, no matter how great it was, your reaction would be a lot like Mark Twain's when he listened to a speech from a returned missionary who went to Africa.
The man told us about the sufferings of the natives, and he pleaded for help with such moving simplicity that I mentally doubled the 50 cents I had intended to put in the plate. Then he continued, and I felt that all the cash I carried on me would be insufficient. Then he went on. He went on and on and on. And when the plate came around, I took 10 cents out of it.
So I'll make a separate episode for Dr. Levy's wonderful interview, but include just this one clip in this episode. The founding mission of the study was to figure out the cause of heart attacks and strokes. So what have they learned about one of the major causes, high blood pressure, in 75 years?
We know pretty definitively that high levels of salt in the diet increase levels of blood pressure moderately. We also know some people have rare genetic diseases that can cause very severe levels of high blood pressure. Those conditions are very uncommon, but help us understand some of the genes that cause high blood pressure, and almost all of those genes that cause genetic forms of hypertension are involved in salt regulation and the kidneys handling and excretion of sodium. But we know from genetic studies that Framingham was an important part of, that there actually are over 2,000 genes now that contribute to blood pressure regulation. Some of them may alter blood pressure by only a fraction of 1 millimeter of blood pressure. But in conjunction, if you were dealt a bad hand, you can have hypertension on the basis of the aggregation or the accumulation of many bad cards that lead to higher blood pressure. Blood pressure medication is a much more powerful way for most people to lower their blood pressure effectively, because while being on a very strict and very low salt diet can lower blood pressure quite substantially, for many people it's difficult to undergo that kind of dietary change. We have enormous amounts of salt in our processed food, even in the bread that we eat.
So I opened by noting the fascinating data that the Framingham Study collected during America's transformation from the weight we once were. We've all speculated endlessly about the rise of fast food, for example, but Framingham has real data. For example, they published this paper way back in 2007 showing that obesity is partly contagious, and it spreads among social circles. They have data for BMI, location, both friend and family ties all over time. And it's all public. So Yale professor Nicholas Christakis could construct a network model to see it in action. He gave a fascinating TED Talk about it with 2 million views, which I'll link in the description.
So bigger dots are bigger people, and we color the dots yellow if they're properly obese. And on this image, we only show two kinds of relationships. The gray lines indicate spousal connections, and the purple lines indicate friendship connections. And what you're going to see across time is you're going to see people be born and die. Images, nodes are going to appear and disappear. Okay, so now you're seeing the network evolve. People are marrying and divorcing each other, friending and defriending each other. You're going to see people gain weight and lose weight. Mostly they're going to gain weight. Now you're going to see the growth of the epidemic. You're going to see mostly a sea of yellow at this point in time as the epidemic is really kicking off. And we're approaching the end of the animation now in just a moment. And by the end, you can see that there are clusters of obese and non-obese, yellow and green sectors within the network. So for example, your friends say, let's go have muffins and beer. It's a terrible combination, but your friend suggested it, so you copy your friend's behavior and you gain weight as a result of the muffin and beer diet that you've assumed. We found some suggestive evidence that as the people around you change their body size, it resets your expectations about what an acceptable body size is, and so you go on to gain weight or lose weight accordingly as well.
Imagine if that animation had ended in 2024, how much yellow we would see. Mathematically, they calculated a person's chances of becoming obese increased by over 50% if they had obese friends. I have always wanted to construct a social graph like this for beliefs about nutrition, which are contagious. If you believe Ansel Keys was an evil fudger of data who pioneered the low-fat craze, then your information network probably involves pop book authors and internet influencers who are not conducting research studies. If you believe Ansel was an extraordinary scientist who popularized the Mediterranean diet and olive oil, then your information network probably involves actual scientists, such as Daniel Levy, who do conduct credible research studies like Framingham. Framingham has witnessed a lot more about obesity over 75 years. For example, Dr. Levy notes in his book that it's only during the 20th century that our marbled, tender meat came from sedentary cattle. Marbling and confinement to restrict movement has accelerated dramatically over the last 50 years, resulting in much higher calorie, higher fat, and lower protein meat than humans have ever been exposed to before. And marbling has been achieved largely by breeding, which means grass-fed beef is marbled too. So what's my big takeaway from this episode? When I was in tech, we had this saying that engineers are not good at science and scientists are not good at engineering. So, to achieve great breakthroughs like NASA's moon landings or Google's search engine, it takes intense collaboration between both the best engineers and the best scientists. And who are the best? The ones who actually do engineering and science, not the social media stars and journalists who only talk about it. I feel like nutrition is a parallel universe. Most doctors are not the ones you want to do your statistical analysis of data, and most scientists are not the ones you want to do your surgeries. It takes the best of both to intensely collaborate and actually do difficult research, and not just talk about it or dabble in it. The problem is researchers don't have time for social media, except for maybe the occasional appearance on TED.
I am a neuroscientist.
So I've been an AI researcher for over a decade.
Many doctors who devote the time it takes to become social media stars have very shallow understanding of science, and I feel the same is true of many scientists who have the degree but don't actually conduct the research. Fad diets come and go, industry-funded studies make splashy headlines for a while, social media stars tell us what we want to hear, but I feel we're so very lucky to have great studies that do stand the test of time, and Framingham may be the best of them. So why don't most of us know much about the Framingham Study? Well, industry has no incentive to mention it because the Framingham data is so unkind to all the most profitable foods to sell. And the popularity of influencers follows the popularity of meat. For example, the left side of this chart shows the subscriber count of influencers who promote meat, and the right side shows influencers who emphasize fruit and vegetables. And if I were to include people who actually conduct research on this graph, those would be blips. Fortunately for you and me, all the food guides around the world are based on the research, and so are the guidelines from professional societies. It's just the pop book authors and social media stars who don't do science, who tell the people who do, well, I don't do science, but it's obvious to me you're doing it wrong. But Chris, you say, aren't there actual scientific papers that completely contradict the Framingham Heart Study with regard to cholesterol? There are, and they create a sensation on social media. The pattern is they're written by people who are not involved in actual heart disease research, like David Diamond, who's in a department of psychology. Anyone can write them because all they need is an internet connection and a computer. And the British Medical Journal in particular loves controversial papers with a dash of conspiracy to get clicks. I made an episode about them. They invariably draw conclusions from data they didn't collect and don't fully understand. When you watch figure skating, would you rather hear commentary from actual skaters who won competitions?
Look at that deep knee bend, that extension on her landing.
Or athletes from other sports?
Did we just see what we just saw?
Or fans who don't play sports but just talk about them.
Tom Brady is still the most overrated player in sports history.
The Framingham scientists are actually doing science in their specialties, collecting data that has stood the test of time and is changing the world.
They say living in California adds 10 years to your life. Isn't that wonderful? I think I'll spend them in New York. Oh, yes, that's a good one. Give it to me. Give it to me. Oh!